Thank you. Thank you. Good afternoon, everyone. Thank you so much for the invitation and my second colleagues for organizing this conference. And also, I had in my mind one conference ago when I started to speak during the IRAS last time. So I have just small advertisement also at the end of the presentation. Today, I want to share with you some observations about the strain energy density factors sacral driving force. As we saw at the morning session, we also were focused on fatigue problems, but connected in the initiation range. And also, in some sessions, we observed the problems with description of the fatigue growth rate. We still use the same approach. So the outline of the presentation is just brief, short motivation, and maybe kind of the description of delta K approach, which is not widely accepted, and of course the easiest way for the description of particular growth. Just let me put some observations about the particular growth rate from energy point of view, but just in a brief discussion because due to time limitation, I want to present only one approach. And also the final stage will be summary conclusions and some advertisements. The motivation for investigation of crack growth and force fatigue is always clear. So I want to discuss that the problem of most models, especially devoted for mode 1 loading, is still problematic since we use since we use multi-axial loading. So if we look on the map, we can see that if we have the number of cycles required for failure, and of course the load irregularity like wind turbines or bridges, so this is the crucial point in modeling to provide robust resistant models for instance, stress ratio. As Professor Sedlak said, the bridges are the most important part, but not so at this time, at this presentation. I think we are on the second place after St. Petersburg with the number of bridges. But of course, to be honest, the guidelines, we can find that it's more than 100, but also including pedestrian areas. So it's not so huge number as we advertise. But of course, many of them were built in the 19th century, and we can also find in Europe or in the world a lot of old bridges, and especially sometimes from time to time find the cracks. And of course, we find the cracks in many different objects. And the key problem is, if you found the crack, how long the crack can be operated. And typically, what is the main problem with the propagation? Of course, I think the most celebrated equation comes from Paris, Professor Paris, who also was in Belgrade in the CF conference. Remember?
No. Right here. Paul Paris was in the family.
Sorry. Yes, that's true, but also it will be about the geo-integral later. So I memorized. And of course, delta K rising to the n power with the C is the most like EMC squared in the physics equation in fracture mechanics crack growth. But in fact, sometimes we have a lot of problems with the proper description. For instance, if we see different stress ratio, we still need to calibrate. Of course, we can use different models, but which one is correct regarding the EMC square? I found one interesting, let's say, statement comes from Albert Einstein that this is the maybe mystery of the fatigue growth rate description, but we always try to pick the experimental data and also discuss in the semi-empirical properties. But if we look, for different calculations, we still use in books or fracture mechanics, which very simple approach, also adapted for numerical methods using, for instance, Paris law, or maybe Walker, or maybe Foreman, with respect to the stress ratio, or maybe if someone is interested in the more deep details, can use, for instance, Foreman-Matthew, or maybe Glasgow equation, which is 9 parameters model. So it's really hard to find the constants for this model. And we still use Paris law, but it's the easiest and the cheapest, let's say, from the experimental perspective. Also, we use the force criterion for measuring the final stage of the crack growth. And finally, we can compute by integration of the differential equation. However, if we find something different, for instance, I just want to, let's say, screen all generation of the models based on the dissipated energy, we can build not one, not tens, but hundreds of the different models connected to the dissipated heat, energy, strain energy density, various factors. In this case, it was a kind of model based on the hysteresis loop area. And of course, what is the main advantage of this? That this model is insensitive for the description with respect to the stress ratio, which was, of course, quite fair for modeling, but of course, it is not fair for engineers because it's very hard to use due to much complicated definition of the delta H crack-driving force parameter. And in the next steps, when I tried to find some relationships between different approaches, I found some important papers that different people, different groups, try to find any relationship between the dissipated energy. One of them is interesting. It's written by Mazzari and Cole. We can see that they compare different energies, and also in previous Pine-Davidson also tried to compare different dissipation of energy. So the key point is where we need to measure the displacement ahead of the crack tip or the load line, many others. Yeah, and also if we look for the modern recent papers with respect to the observation of the hybrid computation of the stress strain analysis ahead of the crack tip, it seems that the quite old idea, which was analytically very popular in the 80s, also 70s, recently, it leads to the conclusion, which was also reflected in some force approach, for instance, by Grze, that the crack driving force could be associated with the two parametric values. In our case, we also adapted some old ideas, and as Professor Grze discussed today about the probabilistic approach, but also we did some papers corresponding with the elementary crack growth, the dissipated energy based on the low cycle fatigue process. And of course, we can find a lot of critical strains, and of course, the concept of plastic zone, cyclic plastic zone, and static plastic zone. And finally, we try to predict the fatigue crack growth rate based on low cycle fatigue parameters. But in fact, if we look inside the equation, we can find quickly that we can interpret some issues as cyclic J integral. Also, this idea is not new because Norman Beckley in 1976 started to describe and introduce the term cyclic J integral to the fatigue crack growth rate description. And of course, from the experimental point of view, it is nice interpretation as a difference in potential energy. And also, when I integration of the models based on the first principle of the thermodynamics and the energy balance between the external energy and the damage work, we also define analytically some results that they are valid that we made with the old model delta H. And in this case, to overcome the limitation of the linear elastic fracture mechanics, we define new delta S star parameter, which is of course root square of positive part of the cyclic J integral as well J bits. And of course, the J can be applied from the experimental, and we're trying to both methods as a crack driving force parameter. From the experimental point of view, the measurement stand, of course, is a little bit much more complicated than classical one. I mean, promoted by STM 647, because for this purpose, we register, of course, the COD, displacement, and the force. But in this case, we need to make our own extra iterate the data by computing the area of the loops, and the loops are not so wide like in low cycle fatigue, so it's a lot of filtering of the signals problems. But this is possible to automate this procedure. And in our case, we tested different type of the materials. One was S355, 41 chromium steel, and of course, one old rich steels. It was not only one, but this one was in our laboratory. So, and for 41 chromium steel, we can see that if we have K max as a driving force, or delta K, we see the shifted crack growth curves. And of course, if we use, in this case, elastic parts, so it's equivalent to the QST approach, we can see consolidation of all data into one point. And also, we thought that maybe if we replace ordinary delta K by delta J as a crack driving force, the problem of the stress ratio disappears. But in fact, it is also noticeable. So we can see that for both type of the materials, we can compare that in case of the energy approach, we see consolidation of all stress ratio into one line. It was done for, of course, mode 1 loading, but the key question always is maybe not so important, but really important at the beginning. If we should apply this criterion for mixed mode loading condition, for instance, like in pressure vessels, just for reminding what's going on. Of course, if we see the number of the papers devoted for mode 1, for mode 2, mode 3, we have still the less number of papers. And in our case, we decided to do a kind of experimental stuff based on the research. This is although the concept was quite smart because it was a plate called compactation shear specimen, and due to changing of the angle in uniaxial meshing at the beginning, it triggered different mixity ratio. Of course, it was necessary to compute the stress intensity factor, but the presented values are valid only for the stationary crack. So it was hybrid experimental and numerical approach with the post processing of the data, because after the crack paths, we need to calculate every point of the crack paths and then calculate the fracture parameters based on the models. And of course, we check the criteria for consistency with the classical for KSMTS or maybe strain energy density. And finally, we plot also the most important part, so crack growth curves, which was registered in the laboratory by observing the crack position in the number of cycles. And finally, we calculate using different load angles, so different mixity ratios, separate modes delta K1 or delta K2. And as we can see, also in the mixed mode loading condition, we are also interested in the specific criteria for balance of the stress intensity factor. There's also hundreds of formulas. Maybe it's a good topic for the next lecture. We use one simple Tanaka criterion, and we can also see that also even if we use delta K effective, delta K equivalent, the problem of stress intensity factors influence with stress ratio still exists. And also, if we use, you can see over equivalent parameter, we have one straight line, which is also nice in the description of particular movement. And also, with the cooperation for colleagues from Apollo University, Professor Zumek, we performed some tests under the mode 1+3. It was bending into the torsion. And in this case, the procedure was the same. So we observed experimentally the crack tip position and finally the number of cycles to failure. And we compute the crack mechanics parameters like cycle J, and of course we can see that for different stress ratio for S355 still we have one crack. And also we try to validate for totally external data. We found in the literature raw data, and we retrieve the data using delta S star parameter, and it was great that we found a good consistency for it. And also, as I probably before, for other iron, so this is the ancient type of the material from 19th century, comes from Eiffel Bridge from Portugal, in cooperation with Grze. We also tested it, and extremely crucial in this case because we have very limited number of specimens for testing. So we are happy to see that the model works successfully. Just to conclude few lines. Of course, this is just only kind of suggestion to follow energy approach, and of course to take some strain energy parameters, which we can easily compute during the simulation process. Of course, in the future, maybe extend for different combination of mode. And at the final stage, I see that we have seen the same problem with the fonts. It was to say thank you and advertisements. I can translate. Yeah, but of course, I would like to invite you all together for the IRAS conference. For me, I was really happy when it was in April last year. I was also a different topic. It was the topic connected with the rubber materials, polyurethane component. And we decided to organize, and we deserve to receive the law for the organizing. And now we are ready, and from mid of November, so quite fresh, we started to advertise this conference. And probably you are the first auditorium who is able to see our advertisements. And of course, please save the date. It's 11 to 12 September. I know that it is many conferences, so only 2 days. And also, as Professor Sedmak said, we plan to organize BAP, Blended Intensive Program for students and PhD students in Wrocław, and you're all warmly welcome. Okay, so Poland, Wrocław, this is the southwest part of the Poland, so it's not so far, let's say, more or less from Belgrade is 120 minutes flight. 2 words about the Wrocław. Wrocław is one of the largest cities in Poland, city of bridges, and of course, bridges and the dwarves. So when I met yesterday in cocktail, my colleagues from Serbia, they told about the bridges and the dwarves. So please discover all together. So thank you very much and see you soon in Wrocław.